Hey everybody, so in this video what we're going to do is we're going to use the Pythagorean Theorem in an application. Okay, so the question that we're being posed is a man is standing on top of the Empire State Building. If he looks out, how far can he see? Now, to solve this problem, what we're going to do, or what I've always done, is we're going to draw a picture. So the first thing that we want to do is let's start out by drawing a picture of the Empire State Building and then the man standing on top of the Empire State Building. Okay. So in some information that we're given, we know that the man is going to be 6 feet tall. Okay, that's reasonable. And we also know that the Empire State Building is 2,652 feet. Okay, I guess that's reasonable. So then what we're going to do is we're going to add the two numbers together. So we're going to get 2,658 feet. Okay, I mean, I see that we have this this addition of the man's height and the Empire State Building. I'm okay with that so far. But how are we going to answer this question of, if he looks out, how far can he see? So what we're going to do is we're going to do we're going to draw the Earth. And I know it's a very poor drawing, but, you know, it is what it is. So what we're going to do next is we're going to draw in the man standing on top of the Empire State Building. Okay, so we have the man standing on top of the Empire State Building on Earth. Obviously, it's not a scale drawing, but, you know, we do the best we can with what we got. And the reason we draw it like this is because we want to make it very apparent as to where the man is actually looking on Earth. So we're not going to draw a sight line from the man just looking out in space, but we actually have to draw the man looking at a point on Earth. So what we're going to do is we're going to take a line from his eyes all the way to a point on the Earth. So let's draw that in. And we're going to pretend like the point crossed right here. Okay, that's reasonable. But at first you still really don't see, you know, how we're going to measure this distance. We have to figure out what this distance actually is. So let's put a question mark right there. So what we're going to do is we're going to use the Pythagorean Theorem. And this is the most important part of the entire problem. So underneath the globe, we're going to write in a squared, then we're going to write plus b squared is equal to c squared. Okay, so that we know that is the Pythagorean Theorem. Okay, like I don't know what we're going to do with that yet, but, you know, let's try to figure something out. So we want to find a point on the Earth that is equidistant, or supposedly equidistant, which means that all the points are the same distance from one point. And that is going to be the center of the Earth, the core. Now, I know in practice that is not true, but we're just going to assume that. Okay. I kind of see like a triangle, like if you draw a line from the top of his head to this point, and then from the center of the Earth to this point. So let's draw that in. Okay. So we have this triangle, but what we know about the Pythagorean Theorem is that we need a right triangle. Okay. Well, the thing that you need to know about this problem, and that I need to know, is that at every tangent point that brings two lines together, we have a right angle. That is the pivotal, most important part of tangential points and lines. So, what we know from the Pythagorean Theorem is that opposite from every right angle, this right angle right here that the man is looking at on the Earth is going to be side C. And then it doesn't matter whether this side is A or this side is B, but we'll just write it in as A and then B. So we put a question mark where side B is, so that's going to be an indicator as to which side we're actually going to be solving for. Okay, so now we have a diagram of the entire problem. But we don't have lengths. We don't have measurements where we can actually solve for a numerical value for side B. How are we going to do that? Well, we need some important facts, and this one thing you're going to be given in the problem is that the radius of the Earth is 3,000 963 miles. Okay, that's... I don't know what I'm going to do with that yet, but we'll figure it out. So what we notice is that from this point, the middle of the Earth, the very middle of the Earth, to the tangential point right over here, where the man is actually looking, is the radius of the Earth. So we can label A is going to be 3,963 miles. Sweet! Okay. What we know about solving equations is that we need only one unknown variable. So that means we either have to find C or find B. And the side that's going to be easier is going to be side C. Okay, so how are we going to do that? Well, we have to add this part, part 1, I'm going to label it part 1, and then we have to add this part, part 2. So 1 plus 2 is going to equal side C. But what we just did, we know that from the absolute core of the Earth to the ground is going to be 3,960 miles. So we can just label that in. So we have, for 1, 3,963 miles is the first distance. But then we have to add in the second distance. Okay, that sounds reasonable. Why don't we do that? So, how are we going to do that? Well, we already did that. We know that from the bottom, or from the ground to the top of the man's head is going to be 2,658 feet. So let's just put that in there. Okay, so we're going to have 3,963 miles plus, let me label miles, plus 2,658 feet is going to equal to side C. But there is something fundamental that we need to remember about math. And that thing that we need to remember is that miles and feet are not the same, and you cannot add them together. So we need to convert either miles to feet or feet to miles. So what I'm going to do is I'm going to come up to the top, and I'm going to convert. So then we're going to have 3,963 miles plus 2,658 feet. Now the one that's easier to convert is going to be 2,658 feet to miles. And the conversion factor is going to be equal to 1 mile is going to be equal to 5,280 feet. Okay, that's reasonable. Fine, whatever. I'll get over it. Okay, so now what we're going to do is we're going to divide 2,658 feet divided by 5,280 feet to get miles. So we're going to have C is equal to 3,963 miles plus 0.5034 miles. So then C is going to be equal to 3,963.5034 miles. If you're confused about this conversion factor, 1 mile is equal to 5,280 feet, don't worry about it. I'll make a video very soon. So, let's keep moving. So now we have side C and we have side A. So now we can solve for side B. So what we're going to do is we're going to plug it in. So we're going to have 3,963 miles plus B squared is equal to 3,963.504 miles. And we forgot something on here. Both of these miles, these numerical values, have to be squared. So after you square both of these numbers and you subtract over 3,963 squared miles, you're going to have B squared is equal to 3,718.37. So then you're going to take the square root of both sides, and you're going to be left with B is equal to 60.97 miles. We're going to circle that answer, as we have to do on all math problems. And we're going to ask ourselves, is it reasonable if a man is standing on top of the Empire State Building can he see 60.97 miles? I don't know if it's reasonable or not, but what I do know is that that answer could make sense.